Hello everyone, my name is Arpit Sharma. Welcome back to my YouTube channel. In my previous class, we had discussed the basics of integration. Now when it comes to integration and the things which we discussed in our previous video, if you are in grade 11th, it is really helpful for you. Why? Because you know that chapter 2 onwards in physics, the integration starts. You have to use integration in the derivations and other places from chapter 2 onwards in physics. So if you are in grade 11th, it is very helpful for you. If you have yet not watched it, please go back and look at my video of the part 1 of this integration, wherein I have discussed the basics of integration. It will be really helpful. Then if you are in grade 12th, in maths, there is chapter number 7 of your book 2. Talks about integrals. So in any case, it is very directly relevant to you when it comes to math students of grade 12. So in integration, towards the end of our previous class, we had seen there are various methods through which you can do integration. For example, you have integration using substitution method, integration using partial fractions, integration by parts. So there are various methods. Today we are going to look at the first method, that is integration using substitution method. So today we will be understanding what this substitution method is. As I always say, just play the role of a good listener with me, and I assure you towards the end of our discussion you will be in a very good position, a much better position when it comes to understanding the topic integration using substitution method. So what this method is, the word speaks for itself. You need to substitute something in the other function to get the result. What do I mean? For example, you have integration of, you need to do the integration of two functions. Let's say these are the two functions we need to do the integration of, f of x upon g of x dx. So if somehow, like after observing, if I realize if I substitute this function in the other one, will I get something? Right? Now how to do that we'll just do, but yes, this is like a substitution method. We will be substituting one function in the other so that we can get the final result. How will we do that? Let's look at it towards like using few questions. Question says integrate the functions, and the first question is you need to integrate 2x upon 1 plus x square. Right? This is the first question. Now you need to understand that when it comes to integration, especially using substitution method, you need to be a good observer. I always say this, if you can observe the functions well, then this method is it's like a cakewalk for you, right? It will be very simple for you if you understand, if you can just observe. Now how to do that observation, let's look. So let's say my integration is, I am integrating 2x upon 1 plus x square. We have already learnt by now that this is the symbol for integration, and the variable of integration will also come since the function is in x. So yes, you need to have dx with respect to x. Okay, so if I observe that, yes, if I take this as t, right? So let's say I am taking 1 plus x square as t. Now you might be wondering, why am I taking it as t? See, you can take any variable for that matter. You can also take it as y, as z or q, r, whatever you want to, but conventionally we take this notation as t. Otherwise you are free to take any notation. So let's say I took 1 plus x square as t, and if I differentiate this function with respect to x, now you might be wondering that I am doing integration. Why then I am differentiating it? Just slowly and gradually you will realize what benefit it will have if you use differentiation here, right? Let's understand how. So if you will integrate, if you will differentiate this function with respect to x, how or what we will get? We will get differentiation of 1. Now differentiation of 1 being a constant will be 0. It will be 0 plus differentiation of x square will be 2x, right? I hope so far so good, is equal to dt upon dx, is equal to dt upon dx, right? So as you can understand, if I bring this dx here, so what can I write? I can write, if I bring this dx here, I can write it like this. Now why am I writing it like this? Just observe, you have the same thing here. 2x dx, and we have just seen 2x dx can be written as dt, right? So let's substitute it here. So in place of 2x dx, what am I writing? I am writing dt. So integration of dt, and upon 1 plus x square I took as t. Just observe, just look. I took 1 plus x square as t. So I'll substitute it here. So 1 plus x square is t. So I have dt upon t and I need to integrate it. So you very well know this is log, right? This is log t. The formula is, let me write the formula also if you want. 1 upon x dx is equal to log of mod x plus c, right? We already know this. So we are applying this formula here. So we will have log of mod t plus c. Now do not leave the answer in the form of t. T was something which you substituted. It was not a part of the equation. It was not the part of the main question. It was something which you took. So you revert back or put the question back in the variable where it was, in which it was given. The variable used was x. So you need to put it back. So t was 1 plus x square. So I will substitute the value of t again, and I will have log of, in place of t I am writing 1 plus x square, right? So this will be the final answer. You may pause the video to note it down. Alright, let's proceed further. I believe the previous question was understood by you. Let's proceed further. So in the second question it says you need to integrate 1 upon x plus x log x. So let me write it as x, I understand, can be taken as common. So I am writing it like this. Now why am I writing it like this? You will soon realize. If I take x as common, and if I understand and if I observe that by taking 1 plus log x as t, by taking 1 plus log x as t, what will I get? By differentiating it, I'll differentiate it with respect to t, I'll differentiate it with respect to x, right? So I need to differentiate it. So let's differentiate it. The differentiation of 1 being a constant will be 0, right? And differentiation of log x will be 1 upon x is equal to dt upon dx, right? That is what I will get. Now please understand, if I again, the way we have done in the previous question, if I just shift this dx here, if I shift dx here, right, this is what I am getting. I am getting 1 upon x dx as dt. So do you realize, do you have 1 upon x dx? Just observe. Yes, we have 1 upon x dx. Just see. We have 1 upon x dx. So in place of 1 upon x dx, I can write what? I can write dt, right? So I can write this as dt upon this thing, 1 plus log x. What was that? Yes, that is t, right? So 1 plus log x can be written as t. Now please understand, again we have already used this formula previously also. In the previous question also we used. You very well know this can be written as log t, right? It can be written as log t plus c. Now you cannot leave the answer in the form of t. As I told you before, t is something which you took. It was not a part of the main question. So you have to revert back. So t was what? T was 1 plus log x. So let me write it down. Log of 1 plus log x, right? Log of 1 plus log x, or in a mod also you can write, that will be better. Now plus c. This is the final answer. I hope you have understood, right? This is the second part. Let's proceed further. You may pause the video to note it down. Alright, so I hope you have understood these two questions. We have already covered this question and this question, right? So let's talk about the third part, the third question. So here my question says that I is equal to integration of 4x plus 2 times root of x square plus x plus 1 with respect to x. Okay, this is what I have. Now as I just said, you just need to observe that what, by letting which function as t will do you some good. By letting which function as t will help you, you know. So let's see. So if I say let the thing which is inside of the under root. Let's try to take that as t. Generally speaking, the thing which is inside the under root, by taking that as t, we are able to arrive at some productive thing. Let's see how. So if you take x square plus x plus 1 as t, what will you get? Again, by differentiating it, I will get 2x plus, and the differentiation of x is 1 and differentiation of 1 is constant, is equal to dt upon dx. I don't think you have any problem. So if I bring this dx here, it can be written like this, right? So this is what I have. If I bring this dx here, I can write it like this. So do you observe that we have 2x plus 1 here? Now you might say no, or you might say yes. See, let me explain this before we proceed further in the question. There are two ways of taking this question forward now. Number one, you understand that yes, 4x plus 2 by taking 2 common can be written as 2x plus 1. If I take 2 common here, it can be written as 2x plus 1. Right? I don't think you have any problem here. And then 2x plus 1 dx, I got st. So this is number one. Number two, if you don't want to take something as common, you directly want to make this function as what you have here. You have 4x plus 2. So no problem, you can multiply 2. So if I multiply 2 on both sides, what will I have? I will have 4x plus 2 because I am multiplying 2, you know. So here also you will multiply 2. I hope you are getting it, you know, because you have to multiply 2 on both sides. Alright. So this 4x plus 2 dx, which is here, 4x plus 2 dx can be written as 2 dt, right? So in place of this, now I am writing, in place of 4x plus 2 dx, I am writing 2 dt. Now 2 being a constant can be taken outside. I don't think anyone has any problem here. So 2 being a constant came outside. What am I left with? I am left with root of t. I am left with root of t. Why? Because this thing I took as t. Just see, I took x square plus x plus 1 as t. So I have resubstituted it. Okay. So this can be written as 2 times. Now root t can be written like this. We very well know it. Now why am I writing it like this? So that I can apply this formula of mine, that x to the power n dx can be written as x to the power n plus 1 upon n plus 1, right? We already know this formula. So let's apply it here. So I have 2 into t to the power 1 upon 2, using that formula, can be written as t to the power 1 upon 2 plus 1, right? It can be written as t to the power 1 upon 2 plus 1 whole upon 1 upon 2 plus 1, right? And then you have c plus c. So let's proceed further. What can I write this as? Now I can write it as 2 and t to the power 3 upon 2, right? 1 upon 2 plus 1, 3 upon 2. 3 upon 2 and then whole upon, again this is also 3 upon 2. So 3 upon 2. Now upon 2 you can write it here. 1, 2 you can bring here. Okay. And then plus c. So what do I have final answer as? I have the final answer as 4 upon 3 t to the power 3 upon 2. As we know, we cannot leave the answer in the form of t because t was not given to me. It was something which I took on my own, right? So I have to fall back to the main variable. So what was my t? My t was x square plus x plus 1. So I will resubstitute it now back in the final answer. So in place of t, I will write down x square plus x plus 1, right? This is what my t was, and to the power 3 upon 2 and plus c. So this is the final answer. I hope you have already followed this much. All of you must have followed this much, I believe. All right, you may pause the video to note it down. Let's proceed further. All right, now let's talk about some more questions, and by doing these questions we will have even better clarity when it comes to integrating using substitution method. So here we need to integrate x cube minus 1 to the power 1 upon 3, x to the power 5, and since we need to integrate this function, let me write it as I is equal to x cube minus 1 to the power 1 upon 3. Now please understand, since I realize I have x cube here, can I write it in the form of x cube? X to the power 5 can be very well written as x cube x square. I don't think anyone has any problem here, right? So I can write x to the power 5 easily like what? X to the power 5 can be written as x cube dot x square. 3 plus 2 again will give me 5. And the variable of integration, because this question is in x, so my variable of integration will be with respect to x. Alright, so this is what I got. Now why have I done this? As I have told you earlier as well, you need to observe, you need to be a good observer. If you are able to observe that yes, by rewriting x to the power 5 like this, it will do me some good. How? Just let's quickly see. If I take, let x to the power 3 minus 1, if I take this as t, okay, if I take this as t, so please understand, can I say that I can write it as 3x square minus 1 differentiation is 0 is equal to dt upon dx. So dx comes here. I don't think anyone has any problem, right? So dx came here, 3x square dx is equal to dt. Do you see 3x square dx anywhere? Now you might say, I do not see 3x square dx, but I do see x square dx. So no problem, shift this 3 there. We can very easily shift this 3 here, right? So this comes here. Okay, this is what I got. So let me put it back. So what do I make of the integral? I have integration of this thing I took as t. As you can observe, I took this as t. So t to the power 1 upon 3, right? I have to the power 1 upon 3 dot x cube. Now you might be wondering what to do with it. So please observe, if I shift this 1 on the other side, can I say my x cube can very well be written in the form of t like t plus 1? Because I shifted 1 there, x cube can be written as t plus 1. Alright, so I can write it as t plus 1. Okay, and in place of x square dx, what can I write? In place of x square dx, I can write dt upon 3. So I am writing it dt upon 3. I hope this much you have understood. Let me give you a quick recap. What did I do? I just rewrote x to the power 5 as x cube dot x square, and I realized, okay, if I take this as t, it is giving me x square dx. X square dx can be written as dt. Now 3 was there, I brought it on the other side, so dt upon 3, and in place of this, I wrote t to the power 1 upon 3 as it is, and x cube can be written as t plus 1. X cube can be written as t plus 1. Alright, let me now solve this further. So please understand, 1 upon 3 is a constant. 1 upon 3 is a constant here. So it can very easily come out. 1 upon 3 is a constant. It can very easily come outside. What am I left with? I am left with t to the power 1 upon 3 dot t plus 1. So you can open the bracket. You can open the bracket. After opening the bracket, I have t to the power 1 upon 3 plus 1. Because here, if there is no power, there is 1, right? I hope you're understanding. So when I will multiply it inside, it will be 1 upon 3 plus 1. So 1 upon 3 plus 1 will give me 4 upon 3. I don't think anyone has any problem here, right? 1 upon 3 plus 1. Plus 1 t to the power 1 upon 3 into 1 will give me t to the power 1 upon 3. No problem here at all, right? This is what I got. Alright, so let me now directly integrate it. Very easily I can integrate it now, and I can write it as t to the power 4 upon 3 can be written as t to the power 4 upon 3 plus 1, right? And then plus upon 4 upon 3 plus 1 here, and then plus t to the power 1 upon 3 can be written as, after integrating, like this. I don't think anyone has any problem here so far, right? Okay, so now 1 upon 3 is as it is. I can write it as t to the power what? 7 upon 3, right? 7 upon 3, and here 7 will come here, 3 I can very well write here. Similarly, this can be written as t to the power 4 upon 3, and here also I will get 4 upon 3, 4 here, and 3 I can write on the up, right? And plus c as it is. Alright, so this is what I believe everyone must have followed. Okay, so now let me make more space. Alright, so now since I understand that yes, 1 upon 3 is a constant, is written outside as it is, or you can multiply it inside also. So 1 upon 3 into 3 upon 7, and t cannot be left like this. You have to resubstitute it. What was your t? Your t was x cube minus 1. So in place of t, I will write x cube minus 1. My t is x cube minus 1. So x cube minus 1 to the power 7 upon 3, right? Then plus, again 1 upon 3 can be multiplied inside. So 1 upon 3 into 3 upon 4 t. My t is x cube minus 1. Let me write it again. X cube minus 1 to the power 4 upon 3. Now plus, you have actually c upon 3 because 1 upon 3 will be multiplied with c also. But again, that is a constant, right? So you can write, let's say, a capital C here, okay? And in the bracket, if you want, you can mention, let 1 upon 3c is equal to capital C. Okay, you can mention that if you this if you want. All right, so this and this is cancelled. What am I left with? I am left with 1 upon 7 x cube minus 1 to the power 7 upon 3 plus, again 3 and 3 got cancelled. I am left with 1 upon 4 x cube minus 1 to the power 4 upon 3 plus c. I don't think anyone has any problem here. All right, let's proceed further. I hope this question you have very well understood and you have noted it down as well. All right, let's proceed. So if I have to integrate this function, again we need to put this symbol of integration and we need to put the variable of integration. So let's put it here. I is equal to integration of 1 upon x times log x to the power m dx, right? So let me write it here. Okay. So let me observe what should I take as t, and just by mere observation you can understand if I take my log x as t, I will get 1 upon x. Are you able to make that observation? If I take my log x, as t, and when I differentiate it, I will get 1 upon x, right? And is equal to dt upon dx. Now as we know, we will shift this dx here. So dx can be written here, right? So 1 upon x dx can be written as dt. So do I observe, am I able to observe that I am getting 1 upon x dx here also? Just observe, yes. And so that means in place of 1 upon x dx, what can I write? I can write integration of 1 upon x dx can be written as dt, and upon, it was log x to the power m, and log x I have already substituted as t, so it will be written as t to the power m. I hope you are getting it, right? So log x to the power m can be written as t to the power m because my log x was t. So this, if I bring it up, will be written as t to the power minus m, right? And integration of dt. I hope you are very well understanding. I brought the power up. So using this rule or this formula, x to the power n dx can be written as x to the power n plus 1 upon n plus 1 plus c. So let's apply it here. So it can be written as I is equal to t to the power n plus 1. My power is minus m plus 1 whole upon minus m plus 1 and plus c. Right? So what is my t? I need to put it back. My t is log x. My t is log x. So let me write it here. So basically my final answer is coming out to be t. In place of t I am putting log x back. So log x, and it had power as minus m plus 1, right? So it can be written as minus m plus 1 and whole upon minus m plus 1, or it can be written as 1 minus m. Right, you can write it as 1 minus m also, and plus c. So this is the final answer, right? So you may pause the video to note this solution down. All right, so let's proceed further. So I believe these questions so far have been understood by you. So let's try to solve other questions. Now my third question is, right, and I need to put my variable of integration, that is dx. So please understand, please observe. All right, so if I make the observation in this function, what should I take as t? So if I take sine 2x as t, right, so let me write down, let sine 2x is equal to t. And if I write this, and after differentiating, what will I get? In place of sine, I will get cos 2x, and as per chain rule, do not forget to apply chain rule, because the differentiation of sine 2x is cos 2x, very right, but you need to apply chain rule here, right? So the dot differentiation of 2x, so dot differentiation of 2x will give you 2, right? So this is what I got after differentiating sine 2x, and is equal to dt upon dx. Do you understand, or do you observe that do you have cos 2x there? And you realize that yes, I do have. So let's say 2 you shift there, cos 2x, dx I am bringing with cos 2x, so dx I am bringing here, and since I do not see any 2 there in multiplication, I'll bring it down. So this is what I can write my cos 2x dx as, right? So cos 2x dx can be written as dt upon 2. So let me write it here. So my I is equal to integration of root of sine 2x, root of sine 2x. Now sine 2x I took as t, so it can be written as root of t, and this is what, dt upon 2. So this is dt upon 2. I hope you're understanding, right? So 1 upon 2 being a constant will come outside, and you have integration of root t. Now root t can be written as 1 upon 2, right? Power is 1 upon 2, and dot dt. Now again you can apply this formula which we have been applying many number of times by now. X to the power n dx can be written as x to the power n plus 1 upon n plus 1, right? Let us apply it here. So I have my final answer as 1 upon 2, integration of this will give me t to the power 1 upon 2 plus 1. Now 1 upon 2 plus 1, I am writing it a bit directly. It can be written as t to the power 3 upon 2, and whole upon 3, and 2 will come here. I hope you're getting it, right? This is what I am getting. And now there is plus c. I don't think you have any problem here, right? Now again you need to substitute it back. You need to substitute the value back. What will you get? 2 and 2 got cut. In place of t, what are you putting? You will put what t actually was. Your t actually was sine 2x. So put it back. So it will be sine 2x to the power 3 upon 2 as it is, and whole upon 3 still remains, right? Plus c. C is a constant, it's an arbitrary constant. I hope this much you have understood. You may pause the video to note it down. This is the final answer of this question, right? Okay. So let us come to our another set of questions, and I believe through these questions you will have a very comprehensive understanding when it comes to substitution method. So let us try to understand them. You have to integrate cot x log sin x. Now see, if in exam, let me write it clearly for you. This can be written as I is equal to integration of cot x log sin x dx. Now if there is no x present with log, so this should be read as log of sin x. Make a habit of reading the functions clearly, so that if you read them clearly, you understand for a fact that it is not log into sin x, it is log of sin x, right? So you can put a bracket also for your reference and for your convenience. So understanding that yes, it was not log x sin x. Had it been log x sin x, it would have meant log x into sin x. There would have been two different functions. But right now I just see log sin x. That means log of sin x, right? So this should be written in the bracket so that it is more understandable to you. All right. So what observation am I making? I am saying if I take log of sin x as t, if I take log of sin x as t, what will I get? I will get, after differentiating this, what you will get? Log of x is 1 upon x, right? Log of x is 1 upon x. So 1 upon, what is your x? Your x is sin x. Your x is sin x. So sin x. Should I apply chain rule? Yes, never forget chain rule, right? And I have already told you chain rule does exist in integration also. The difference being in differentiation, the chain rule applies in multiplication. You know, you multiply what you get after differentiating. But whereas in integration, chain rule exists there also. But since integration is the reverse operation of differentiation, the chain rule will be applied in division, right? So let us get back to differentiation first. So dot derivative of sin x, as per chain rule, I will get cos x. I hope you are getting it, right? Is equal to dt upon dx. Now you can very well understand 1 into cos x is cos x. So cos x upon sin x. What is cos x upon sin x? Yes, very good. You have guessed it right. It is cot x. So cot x and dx can be brought here is equal to dt. I hope you're understanding, right? So do you see, is there any cot x dx? And you make an observation that yes, there was cot x along with dx. Just see, cot x dx. Now in place of cot x dx, what can I write? In place of cot x dx, I can write dt, right? So I'm writing dt, and I have log of sin x. So log of sin x. What was log of sin x? What was log of sin x? Rather than writing log, I should write t, because my log of sin x is t. So just t. I hope this much is understood, right? My entire question is in t now. So now you can easily integrate. So I is equal to, if there is nothing, there is 1, right? So it can be written as t to the power 1 plus 1, that is 2 whole upon 2 plus c. And you need to put the t back. You cannot leave the answer in t. What was your t? Your t was log of sin x. So put it back. So log of sin x, and since there was to the power 2, so put the whole power as 2 and whole upon 2 plus c, right? This is the final answer. So this is the final answer when you integrated this. You may pause the video to note it down. All right, let's proceed further. This is what you have: x cube sine tan inverse x to the power 4 whole upon 1 plus x to the power 8. Again, you just need to make an observation. What should I take as t? So you realize, if I take, let tan inverse x to the power 4 as t. Now why am I saying this? All right, so derivative of tan inverse x is what? 1 upon 1 plus x square, right? This is the derivative of tan inverse x. Now if I substitute this thing here, let's try to use this. We will try to substitute this in the question. Okay, let me write it somewhere here. Okay, all right. Now look, so if I say let tan inverse x to the power 4 be t, if I take this as t and if I differentiate this, what will I get? I will get 1 upon 1 plus x square. Now my x is x to the power 4, as you can see. What is my x? My x is x to the power 4. So x to the power 4 whole square, right? Because the derivative of tan inverse x is 1 upon 1 plus x square. So 1 upon 1 plus x square. Then this will be equal to dt upon dx. Right? Now, before you do this or before you complete this, please try to understand there is a chain rule also which needs to be applied. Chain rule also we have to apply. How? Because we said the derivative of tan inverse x to the power 4 is 1 upon x to the power 4 whole square. But as per the chain rule, I also have to differentiate x to the power 4. So x to the power 4 differentiation will be 4x cube. Right? Very good. So let's proceed. So x cube, is it helpful? Is it useful? As you can see, I can write it as integration of this dx, right? So do you see x cube upon 1 plus x to the power 4 whole square, or which can be written as 8 also, x to the power 4 2 can be written as x to the power 8, and this 4 is extra and I can bring it down, right? I can bring this 4 down. This 4 I am bringing here and dx has gone there. So do you see that yes, this is something which you can use here. As you can see, x cube upon 1 plus x to the power 8 dx can be written as dx upon 4. So what do I have? I have x cube upon 1 plus x to the power 8, and look here, this is dx, right? This is dx here. So in place of this, what can I write? I can write dt upon 4. So let me write it here. My I now has become, in place of that entire thing which I have highlighted in the yellow, I can write dt upon 4. So dt upon 4, right? Now please understand, what is left? I am left with sine, and this thing, tan inverse x to the power 4. What was that? Just look here. Tan inverse x to the power 4 was t. So I can write it as sine t. I hope so far so good. So this is I is equal to 1 upon 4 is a constant, it has come out, and the integration of sine is minus cos, right? Integration of sine is minus cos. So minus cos t, right? And I cannot leave the answer or the final answer in t. I have to again put it back. What was my t? My t was tan inverse x to the power 4. So my final answer will be minus 1 upon 4 cos t. My t is tan inverse x to the power 4. So tan inverse x to the power 4, and plus c is as it is. I hope you have understood so far, right? You may pause the video to note it down. Alright, let's move on to the third part. In the third part it says e tan inverse x upon 1 plus x square. So we already have used it, we will be using it again, right? As you can see, if I take tan inverse x, if I say let tan inverse x be t, so what can I say? The derivative will be 1 upon 1 plus x square is equal to dt, and dx I am bringing here, dx came here, right? So is it serving you some purpose? Just see, I have 1 upon 1 plus x square dx can be written as dt. So I have this. In place of this, I can write dt, okay? So I have I is equal to integration of dt and e to the power t, because e to the power tan inverse x it was, and tan inverse x is equal to t. So e to the power t it is, right? So now e to the power t integration is et as it is, it does not change its position, and plus c. Now I cannot leave the answer in the form of t, I have to again resubstitute it. My t was tan inverse x, so I'll put it back again here. So e tan inverse x, right, plus c. This is the final answer. I hope you must have followed till this point. Alright, so this completes our discussion of the method of substitution, integration using substitution. So this completes the discussion. I hope you have understood the concept. Make sure you practice more questions on this topic, and the more practice you will do, the better you will be at it, and the better command you will have over this topic. Okay, so I hope you have followed it. Let me know if you want me to make any other video in the comment section, and very soon I'll be making a video on that so that you all may be benefited. Alright, may God bless you all and take care.